from section 1, make sure, and this is P2, page 22, as we go through this, make sure you know all your rules of exponents. And when I say know them, that involves even if they were fractional exponents, even if there were variables in the exponents. So don't just know that x squared times x to the third is x to the fifth. Know that you have to add those, but not just that. What if you had 4 to the x times 4 to the 2x? Be able to apply it if there's variables in the exponents. Be able to apply it if you had like 3 to the 1/2 power times 3 to the 1/3 power. To know that you when you're multiplying like bases, and you're not doing anything with the bases stay the same. But 4 to the x times 4 to the 2x would be 4 to the 3x. 3 to the 1/2 times 3 to the 1/3, let's see, common denominator would be 6, at 3, 6, 2, 6, that'd be 3 to the 5/6 power. But that's one of your rules. Like bases, multiply them, add exponents. Powers to powers, 4 squared to the 3rd power. Power raised to a power, make sure you're multiplying exponents. The bases do not change. Division. Let's look at this one. Here's a division problem combined with negative exponent. So again, combining negative exponents with your what to do with fractions. 6 over 8. Divide it if you can divide it. If you can't divide it, reduce it. If you can't reduce it, leave it. 6 over 8, that's going to be 3 over 4. Reduces. Still got your fraction bar. When you're dealing with negative exponents, make sure you're making a positive. So a negative exponent to make positive. Notice here, again, from what we talked about yesterday, there's no pluses or minus signs. So it's legal just to move it across that fraction bar. X to the negative 4 comes to the top, becomes x to the positive 4. You already had one up there, so now you have 5 of them. There's 2 y's on top, 3 y's on bottom. Do it however you see fit. If you want to subtract those and do 2 minus 3 and get negative 1, that's fine. Okay. The way I do it is I see there's more on bottom, so I subtract it and I put my answer on bottom. Since there's more on bottom, 3 on bottom, 2 on top, subtract that, that leaves me with 1 on bottom. Nothing else simplifies inside there, so we're done inside. When a fraction is being raised to a negative exponent, make sure you flip your fraction. 4y is now on top, 3x to the 5th is now on bottom. And it's raised instead of the negative 3 power, it's raised to the positive 3. Last step, again, there's no pluses or minuses. Had there been a plus or minus raised to a 3rd power, you're going to have to FOIL it out. Since there's no pluses or minuses, just raise all 4 of these things to the 3rd power. 4 to the 3rd, y to the 3rd, 3 to the 3rd, x to the 5th to the 3rd. 4 to the 3rd is 64. Y to the 3rd is y to the 3rd. 3 to the 3rd is 27. And x to the 5th to the 3rd, power to power, multiply. X to the 15th. Moving on to P3, make sure that you know the relationship between fractional exponents and radicals. The number on bottom is the root. The number on top is a power. And some of those you will be able to simplify. Like if I gave you, let's say 8 to the 2/3 power. And it's usually easier to do the bottom root first and then raise it to the power. This would be the 3rd root of 8. And then raise to the 2nd power. And I don't care if you put the 2 inside, outside, I don't care about the 2. First step, 3rd root of 8 is 2. And 2 to the 2nd power is 4. You will have to simplify some radicals from P3. Let's do the square root of 24, x to the 8, y to the 13th. These problems do need to be split. I'd split into root 24, root x to the 8th, and root y to the 13th first. And then split that into things that you can take the root of. Square root of 24. Somebody help me with that. What's the perfect root in 24? Biggest one is 4. Square root of 4 times square root of 6. Can you take the square root of x to the 8th? And again, here's where it goes back to, it's valuable to be able to rewrite it. The square root is the same thing as, well, the bottom number, if you want to raise that to write it as a radical, a rational exponent, the bottom number is the root, the top number is the exponent. So that's x to the 8/2 power. Oops. And can you divide 8 by 2? Yeah. That's x to the 4th. So we can go ahead and just take that out completely. That's x to the 4th power. The square root of y to the 13th. 13/2 power. You can't do it. Whoops. That's a base. We can't do 13/2 power, but we can split this. Let's split into the square root of y to the 12th times square root of y. Because we can do 12/2 power. Had that been a third root, you would want 12 would have also actually worked again. If it had been a third root, though, you would want to split this into y to the 3rd, y to the 6th, y to the 9th, y to the 12th, a multiple of 3. So now let's clean this up. Square root of 4 is 2. We've already took x to the 4th out. The square root of y to the 12th, that's 12/2 power, that'd be y to the 6th. The stuff under the radical, leave under the radical. That's how that would simplify. And again, if I go too fast for you, I am recording this, so if you need to go back throughout the day, I'll post it ASAP. Actually, I'll probably post it while Northeast is still here. Operations. Square root of 20 plus square root of 5 cannot be done unless it simplifies into something that has the same radicand. The square root of 20 is the square root of 4. Is everybody okay with the square root of 4s too? Square root of 20 is the square root of 4 times the square root of 5 plus the square root of 5. So now you have 2 root 5 plus 1 root 5, which is, that's kind of like 2x plus 1x, which is 3x. Even though you can't add them like they are, you can multiply them. Square roots can be multiplied. Let's make this a little bit harder. Let's do 3 root 20 and 4 root 5. When you're multiplying radical expressions, a number cannot be multiplied by a radical. Numbers can be multiplied by numbers, radicals by radicals. This would be 3 times 4 is 12. Root 20 times root 5 would be root 100. 12 root 100. Which is the same thing as 12 times the square root of 100 is 10, which is 120. I just made that problem up. The same way you can't multiply numbers with radicals, you can't divide numbers and radicals. We've got to get rid of this radical on bottom. It's called rationalizing. Anytime I ask you on your test to rationalize, I'm not trying to get you to explain to me why you can't do it. I'm getting you to try to get the root off the bottom. Different type of rationalizing. Multiply top and bottom by root 2. To get a I say that. Multiply the top and bottom by a radical that would remove the radical. The easiest here would be root 2. You don't have to use root 2 if for some reason you like root 8 and would like to multiply top and bottom by root 8. That would give you a root 16 on bottom, which you also know. If you want to multiply top and bottom by root 50, that's fine, because that would give you a root 100 on the bottom, which you know. Okay, I do root 2. On top, you now have 3 root 2. On bottom, you have the square root of 2 times the square root of 2, which is 2. You would check next to see, okay, can these numbers be simplified? Since they cannot, you're done. We've already worked this one in your notes, but root 40 divided by root 5, radicals can be divided. Square root of 40 divided by the square root of 5 is the square root of 8. And that would simplify into 2 root 2. But you can divide radicals as well. And I'm trying to speed through this as much as possible. If at the end there's other things that you'd like to see work, please let me P4 was complex numbers. Make sure that you know your powers of complex, and I'm going to start speeding up now. I to the first power, obviously, is I. Anything to the first power is just itself. I to the second power is -1. I to the third power is -I. And I to the fourth power is +1. I to the fifth power, I to the sixth power, I to the seventh, I to the 8th, 9th, 10th, 11th, 12th, 13th, 14th. It's cyclic. It keeps going. Okay? So I to the 40th power, here. I to the 41st, 42nd, 43rd, 44th. Any power of 4 will always fall right there. So make sure that you know how to raise imaginary complex numbers to powers. If you are multiplying them, let's do a conjugate. Please make sure you know what the word conjugate means on the test. If you're multiplying them, when you're multiplying conjugates, all you have to do is 2 times 2 is 4. Positive times negative will be a negative 9i squared, because you got to multiply 3 times 3 and I times I. Anytime you're left with like I squared or I to the third or I to the fourth, replace it with the appropriate number. -9 times I squared is -9 times -1, which is actually +9. If I ask you to multiply two negative powers together, the square root of -27 times the square root of -30, let's just do 36. Before you because a radical can be multiplied by a radical, but since you're dealing with imaginaries, please remove that imaginary part before you multiply these together. Square root of -27 is the square root of -1. I'm going to go ahead and put an I in that spot. Times the square root of 9 times the square root of 3. That'd be 3i root 3. Times the square root of -36 is the square root of -1 times the square root of 36. So clean that up. That's what it would clean into. Again, if you were asked to multiply these together, multiply the numbers. 3 times 6 is 18. I times I is I squared. Square root of 3 does not have anything to multiply by, so leave it. If it was another root over there, you'd multiply by it. I squared, again, is -1. So you have 18 times -1, which would be -18 root 3. That's how you'd clean that up. Also on tomorrow's test, and I'm not going to do a whole lot of this, but make sure that you know how to add, subtract polynomials. 3x to the third plus 4x minus 5 minus 2x to the third plus 4x squared minus 6. And again, like I said, I'm not going to do that. It's combining like terms. That's all you're doing there. Make sure you know how to combine like terms. 3x to the third combines with minus 2x to the third. 4x combines with minus 4x. -5 minus -6. Make sure you know how to add, subtract. To multiply them, been there, done that. 2x plus 3 times 3x squared minus 6x plus 2. That would be your FOIL. 2x times 3x squared. 2x times -6. 2x times 2. 3 times 3x squared. 3 times -6x. 3 times -2. You pull it out. Combine like terms. You will have to, be able to divide them. 2x squared minus 4x plus 3 divided by x minus 6. Synthetic division. 6 goes in the box. 2, -4, and 3 go next to the box. The last number you get is your remainder. The next number, or the number next to it, is a constant. The number next to that would be an x term. If there were another, it would be an x squared term. So this would be 2x plus 8. Always write your remainder over what you're dividing by. So plus 51 over x minus 6. So make sure you know how to do synthetic division. Sometimes synthetic division is not required, such as if you had 6x to the third minus 9x squared plus 12x divided by 3x. if you're dividing all of that by 3x, guys, you don't need synthetic division there. You're not dividing by like x minus 3 or x plus 4. You're dividing by 3x. You're dividing by, this is called a monomial. There's no pluses or minuses. So when you're dividing by a monomial, just put it on bottom. Distribute, divide this by 3x, divide this by 3x, divide this by 3x. How do you do that? That goes back to your rules of exponents. 6 divided by 3, x to the third divided by x. 9 divided by 3, x squared. It's distributive property. Okay. Then in P6 we factored. Make sure you know how to factor by grouping. We group when there's 4 more terms, such as x to the third plus x squared plus 3x plus 3. Group the first two, group the last two, pull out what's common. There's a 3 common there. If you work it correctly, if factoring by grouping will work, then you should get the same term or a similar term on each side. That x plus 1 is contained in both of them. That way we can factor that out now. If I pulled an x plus 1 out of both those terms, I'm left with x squared plus 3. Always check to see if you can factor completely. See if you can factor farther. This won't factor anymore. It's linear. It's a line. Okay, x to the first power. This will possibly factor some more. If there's 2 terms, that's when you check to see, okay, do I have a difference of squares? Perfect square difference. That factors into conjugates, x plus 4, x minus 4. Also 2 terms could be a difference of cubes, third power, and that could actually be x to the 6th, x to the 9th. Those are also perfect cubes, minus, I don't know, 27. That's 3 times 3 times 3. Or 8, that's 2 times 2 times 2. Or that could be 64, that's 4 times 4 times 4. So check to see if you have a difference of cubes. I will let you use your formulas on the test tomorrow for difference of, or excuse me, sum of cubes and difference of cubes. I'll let you write those on a note card. You can use those. And that's the last thing. Do I have a sum of cubes? This is none of those. It's a square, and it's not difference of squares, so you cannot factor that any further. You'd leave it there. Also be able to factor quadratic trinomials. There we go. To where you say what adds to give you this, multiplies to give you this. Before you do any type factoring, make sure there's no common factors. There's not here. You'll also possibly have to do a bottoms up. 3x squared minus 2. Actually, let's do that same problem. That's a bottoms up style factoring. How would you factor that? Well, you'd move the 3 to the end and factor it just like this. And then you would go back, and once you've got it factored out, you would divide your 2 constants by 3. And divide, reduce, or move bottom up. You'll have some to where they won't be quadratic, but they might kind of look quadratic, like x to the 4th minus 3x squared plus, let me think, negative 6 positive 3 would work, negative 6 positive 3, negative 18. That's not quadratic, but you can factor like it is, because you have, instead of x squared and x, you have x to the 4th and x squared. You could have had x to the 6th and x to the 3rd. It would still work. To factor that, you do it the same. X squared times x squared. Just don't put x and x. Adds to give me negative 3, multiplies to give me negative 18 would be a negative 6 and a positive 3. Just make sure on these problems, see, could I go farther? 2 terms, 2 terms. Okay, if you have 2 terms, the only way you can factor 2 terms, well, you can see if there's a common factor. But other than that, is it difference of squares? Is it difference of cubes? Is it sum of cubes? That's the only way you can factor two terms. This is not difference of squares unless you want to count 6 as being the square root of 6 times the square root of 6. You don't have to. This is not anything. It's addition. The only way you can factor addition if it's 2 terms is if it's sum of cubes. That's not. So that's as far as you could go with that. You might have one which instead of, I've showed you this, instead of x squared plus 4x plus 3, What if you had, instead of that, what if you had r minus 5 squared plus 4 times r minus 5 plus 3? You do it the same way, okay? You would say, well, this is kind of ugly, but since I have r minus 5's here and here, let's take that out, replace it with another letter. Replace it with like a u. So let's say u squared plus 4u minus, or plus 3. Factor that like normal, u plus 3, u plus 1. And now that I have it factored, go back and put the r minus 5's back in. And just clean it up. So that'd be r minus 5 plus 3, which would be r minus 2. R minus 5 plus 1, which is r minus 4. You're done. Okay? And finally, from yesterday, when you're dealing with rational expressions, make sure you're able to, if I ask you for domain, there we go, 2x plus 3 over x squared plus 3x plus, let's do minus 4. If I ask you for domain are the things that make the bottom equal 0. Are not present in your domain. You cannot have a number divided by 0. So if I ask you for a domain, you would set the bottom, or you'd factor it, which in this case would be x plus 4, x minus 1. And you would say what values of x would make the bottom equal to 0. Guys, if I put a negative 4 right there, negative 4 plus 4, that's 0. 0 times anything, it doesn't matter, it's 0. If I put a 1 right there, it would make the bottom equal to 0. Those two things are not in your domain. So your domain is everything but negative 4 and 1. Can't plug those in. That gives you zeros on bottom. You'll also have to be able to reduce fractions. If I give you x squared plus 3x minus 4 divided by x squared plus 6x plus 8. Biggest thing, do not start marking out x squareds and x squareds. Don't mark out 4 and 8 and reduce it. This cannot be reduced until it's factored. Factor the top, x plus 4x minus 1. Factor the bottom, x plus 2x plus 4. And in order to reduce, start marking out what's common. There's an x plus 4 on top, there's an x plus 4 on bottom. Again, that's called removable discontinuity. We'll talk about it again later on. X plus 4 is canceled. That reduces to x minus 1 over x plus 2. Done. That's how you reduce them. Again, make sure you know how to multiply them. Honestly, guys, multiplying is the same thing as reducing. If you want to just draw when you're multiplying, if you just want to draw one big line between it and do the same thing, it's the same thing. Okay? Just tops and bottoms, mark out everything that cancels out. Division, same thing. Just flip the second. Okay, factor everything, cancel out tops and bottoms, anything that's common. Just don't cancel out a bottom with a bottom. Adding, subtracting, before you can add or subtract, you have to have common denominators. I will work one of those. X over x squared plus 6x plus 9. I'm going to go ahead and factor this as I'm writing it down. X over x plus 3 times x plus 3. That's always your first step when you're adding, subtracting. Factor. Factor all your bottoms. And then you have x minus 3 over x squared plus 5x plus 6, which is x plus 2 times x plus 3. I think this one's actually in your notes. To get a common denominator, and I usually go ahead and put these, if there's a binomial, I'll go ahead and put in parentheses on top. Here you're missing an x plus 2, so just put one. If you're going to put one on bottom, put one on top too. Now all you're missing is an x plus 3 here. So put one on top and bottom. The bottoms are now the same. Now you can subtract them. In order to subtract, let's see, x times x, x times 2, you got to pull that out. My only other word of advice, make sure it's minus the whole thing. And that's conjugates. We like multiplying conjugates. Multiply the first, multiply the last. Over Ditto. So we don't have to rewrite the bottom. X squared minus x squared. 2x minus 9 will be plus 9 over x plus 2 times x plus 3 times x plus 3. Before you can add or subtract, make sure the bottoms are the same. And finally, complex fractions. Y'all see I don't smoking yet? With complex fractions, it doesn't matter what's on top. No, doesn't matter how ugly it is. X plus 6 over x squared minus 9 over x minus 3 minus x plus 4 over x plus 3. It doesn't matter what's on top, what's on bottom. The biggest thing to remember is that your large fraction bar does mean to divide. Treat it as if there's parentheses on bottom. Treat it as if there's parentheses on top. Work it as two separate problems and divide your final answers. Okay, flip and multiply just like you would before. Here we go. On bottom, common denominator. And I always go ahead and put these in parentheses. If I have a binomial, it just makes it look better. Put them in parentheses. Here I need an x plus 3. So put one on top and bottom. Here I need an x minus 3. Put one on top and bottom. Anyway. So on top, let's go ahead and look. And like I said, if you want to work it as two separate problems, that's fine. X minus 3, x plus 3 is what that factors into. It's difference of squares. Now I have my like terms. Let's see, x times x is x squared. And if you want to do this, even come over to the side. I need you some colored pencils like I've got here. Come over to the side, and x times x plus 3 would be x squared plus 3x. X plus 4 times x minus 3 would be x squared plus x minus 12. If you don't know where I got that from, I did x times x. I went ahead and did x times negative 3 and 4 times x, and I combined them. Those middle terms will always combine. And 4 times negative 3 gives you the negative 12. So now I have minus. I've got to subtract all of that. X squared minus x squared goes away. 3x minus x gives you 2x. And nothing, there's nothing to combine with minus 12, so you have 0 minus minus 12, minus minus will be plus 12. A lot of people would miss that symbol right there. Over x plus 3x minus 3. And this is actually the one we worked yesterday, isn't it? Again, what I would do just to save paper, I would see, well, this will factor, so let's go ahead and next to this put 2 parentheses x plus 6, unless you want to rewrite that whole thing. Now, again, the big fraction bar means to divide, so I'm going to flip and multiply. So I've got x plus 6 over x minus 3x plus 3. Times x minus 3 times x plus 3 over 2 parentheses x plus 6. Again, since you have a binomial, if you want to keep those binomials together with parentheses, if you need to see that, cancels, cancels, cancels. Only the 1 is left on top and the 2 left on bottom. And again, I believe we worked that in your notes yesterday as well. So here we go. Another synthetic division problem. Inside the box, what you're dividing by, if it's x plus 4, you're going to divide by the opposite, minus 4. Next to the box, you're going to put these numbers. You have 1x to the 5th. Notice there's no x to the 4ths. Put a 0. You have 3x to the 3rds. You have negative 6x squareds. You have 4x's, and you have x to the 0 powered. Now, something else I would like to point out, you're dividing x to the 5th by x to the 1st. You should get an x to the 4th answer. Okay? You have a question? Huh? It sure is. I was testing to see if you're awake this morning. And you are. I'm not. And then, like I said, I like this one because we've got a ton of steps here, and hopefully you'll see more of what you're supposed to do. First number just comes automatically down. And this will be a terribly ugly problem. I'll go ahead and warn you, because anytime I make up a problem, usually we'll come out with like 23 million or something over here as a remainder. Okay, I should have done more pluses and minuses. Bring down the first number, multiply, always multiply by what's in the box. Multiply by -4. Add these two numbers together, multiply by what's in the box. Add these two numbers together, multiply by what's in the box. Here we go. Add these two numbers together, multiply by what's in the box, 328. Add these two numbers together, 332, multiply by what's in the box, goodness, 12, 128, 1328. Somebody please double check me on that. Add the two numbers together. That's the remainder. The remainder, you can put plus -1331 over what you're dividing by. We're dividing by x plus 4. Don't put it over -4. The next number is a constant. The next number is an x. The next number is an x squared. The next number is an x to the third. The next number should be an x to the fourth. And again, that should make sense. If you're dividing x to the fifth by x to the first, a fifth power, think about how you divide. A fifth power divided by a first power, you'd subtract them, right? Should end up with a fourth power.